Hello friends, myself Ashok Samri. Today we are going to start the new article in amines. The new article like this basicity of amines. You know the basicity of amines. The basicity which is depend upon the stability of these amines. That's why the some factor are responsible or determine the basicity of these amines. That's why I want to take here the first effect of the we determine the basicity like this positive inductive effect. It is represented as plus R effect. You know, plus I effect, the positive inductive effect represent that the more the plus I effect, more the basicity, which is represented, the more the plus I effect, more the basicity. That's why inductive effect, the amine which consists of more the inductive effect, the amines are more basic in nature. That's why I want to take the example of this reaction of this effect like this NH2 the primary amine. Now we want to take here secondary amine. Now here we want to take here tertiary amine. Now the alkyl group is attached to the nitrogen atom, and these alkyl group are the electron donating group, or this electron donating group increase the electron density of this nitrogen atom. Okay, that's why the electron density, that's why these electrons are easily available for the coordination. Now in this case, there is only one alkyl group is there. In this case, secondary amine, there is the two alkyl groups which again increase the electron density of the nitrogen atom. And now in the tertiary amine, there are the three alkyl groups which again more and more increase the electron density of this nitrogen atom. These are the primary amine, these are the secondary amine, and these are the tertiary amine. That's why, according to this effect, more the plus I effect, more the basicity. Now, in this case, in the tertiary amine, there is the three alkyl group attached to the nitrogen atom, and that's why these are the electron donating or electron releasing group which increase the electron density of the nitrogen atom. That's why the plus I effect in tertiary amine is more than the secondary, and secondary is more than the primary amines. That's why more the effect, more the basicity. That's why the order of basicity like this, tertiary is greater than, secondary is greater than primary in the plus I effect in the gas phase. This effect also take place in the aqueous phase also. Now, in the aqueous phase, like that the solvation effect. Now, in the solvation effect, the solution of aqueous medium, it is related to the solution in aqueous medium. That means, in the solvation effect, the amines are soluble in the water through the hydrogen bonding. That's why we have to take the example of this solvation effect like this. We have to take here, these are the R NH2, the lone pair of electron is oxide, is proton in the water molecule formation of NH, cation is formed. structure like this. These are the primary, you know, R and R. The hydrogen, there is also hydrogen is there. In the these are the secondary. Now in this case R and R, or here R, here hydrogen get the cation. Now in this case, this amine which formation of a hydrogen bonding with the water molecule. Now these are the hydrogen bonding with the water molecule. That's why it can be stabilized, this nitrogen atom, by the, in this case there are the 3 water molecule is attached to the hydrogen atom, stabilize this ammonium ion. Primary, there are the 3 hydrogen group is attached to the oxygen, hydrogen atom is attached to the oxygen by stabilization of this positive charge. In this case, there is only 2 hydrogen bonding can form, and in this case, only 1 can form the water molecule. Hydrogen bonding with the water molecule by stabilization of this positive charge on the nitrogen atom. But now in this case, there is the more solvation or take place. That is, the more the solvation is take place in the primary amine, because 3 water molecule is attached through the hydrogen bonding, and that's why the order of basicity is primary is greater than the secondary is greater than the tertiary. The primary amine is more basic in nature. It can stabilize the 3 water molecule, the nitrogen atom. That's why it is more basic in nature in the aqueous medium. Then secondary amine and then tertiary amine. In this way, the order of basicity in the solvation effect, primary amine is greater than the secondary amine and is greater than the tertiary amine. In this way, we can determine the order of basicity in the solution effect. Now in comparison with plus I effect and solution effect, there is the totally opposite to the each other. Then another factor is the steric effect. Now in the steric effect, we have to show that more the steric hindrance is there, but steric influence is more, it is the less basic in nature. More steric influence are there, that's why there is a less basic in nature, and the less steric influence are there are the more basic in nature. Now we have to take here R NH2, these are the primary amine, R2 NH secondary amine, R3N, there are the tertiary. We can represent in this form. How to represent R N H H R N H R, and now we have R N R, here R, tertiary amine, secondary amine. In this case, less steric hindrance, less steric effect, there is only one alkyl group. Now in this case, there are the 3 alkyl groups there, that's why more steric effect. Because there are the 3 bulky group attached to the nitrogen atom. That's why these nitrogen are easily, this lone pair of electron is not easily available in the tertiary amine, but now in the primary amine there is only one alkyl group, there is a less steric hindrance is there. That's why this lone pair of electron is easily available. That's why the order of basicity is primary is greater than secondary is greater than tertiary. Order of basicity. Okay, the more the steric hindrance, less basic nature, less steric hindrance, more the basicity. That's why according to the steric effect, primary is greater than secondary is greater than tertiary. Okay, then now we have to take here plus I effect, steric effect, and the solution effect in comparison with the D combined effect of these three plus I effect. Order of basicity is tertiary is greater than secondary is greater than primary. Solvation effect, primary greater than secondary greater than tertiary. Steric effect, primary greater than secondary greater than tertiary. In this case, the plus I effect tertiary is more stable, more basic in nature. In solution effect, primary tertiary is less stable, less basic in nature. In steric effect, tertiary is less basic in nature. Now, by combining all these three effects, we show that the secondary is greater than the primary is greater than the tertiary. Because of the according to solution effect, primary is more, steric effect is also primary is more, tertiary is less is there. By using some alkyl group, we can show that when alkyl group is CH3, smaller group is there. In this case, whenever the CH3 NH2, CH3 2 times NH, and now CH3 3 times N. In this case, the secondary is in between in all the three effects. That's why the secondary amine is greater than the primary amine, greater than the tertiary amine. In this case, the solvation effect is more. Solvation effect is more than inductive effect plus I effect. But now, whenever the C2H5 or the bulky group is there, or more, the larger group is there, at that time we can show that the C2H5 NH2, C2H5 2 times NH, and then C2H5 3 times N. In this case, we can show that the secondary is greater than tertiary is greater than primary, because it is the, in this case, plus I effect is more than solvation effect. That's why we can remember that in the methyl group is there alkyl group, that secondary greater than primary greater than tertiary. Whenever the alkyl group are the methyl group, and whenever the ethyl group is there, then the plus I effect is more than the solvation. That's why secondary greater than the tertiary greater than the primary. In this way, we can complete the four effects, or we can determine the order of basicity of the amines. Then now we can take some example of this amine, and we can arrange the order of basicity of this amine. We know the CH3 NH2, CH3 NH, CH3 3 times and NH3, and now also here C6H5 NH2. We can arrange the order of basicity. You know, according to this effect, the secondary amine is greater than the primary amine is greater than the tertiary amine is greater than the ammonia, and ammonia is greater than the aniline. That's why these are the aniline. You know why the aniline is lower basic in nature? Because of in aniline there are the formation of high-resonance structure. These high-resonance structure are formed because of the lone pair of electron can delocalize by the 5 resonance structure, and in the resonance and can form a 5 resonance structure. That's why these lone pair of electron are less available by the protonation. That's why these are the less basic in nature. That's why these are the aniline is less basic than the ammonia and these amines, aliphatic amines. Okay. Then also we want to take another example like this ethyl group is there, C2H5NH2, C2H5 2 times NH, C2H5 3 times N, NH3, and then C6H5NH2. In this case, we can show that determine the order of basicity. The secondary is greater than the tertiary greater than the primary, and then ammonia is greater than the aniline. That type of a question will be asking in the examination in NEET and JEE, and that's why we can solve this order of basicity. Okay. In this way, we can complete the basicity of amines.